You know, for decades, the moon has basically just been a glowing orb in our night sky, kind of like this quiet, distant memory of the Apollo era. But right now, we are in the middle of a massive architectural and engineering shift to get humans back onto the lunar surface. Welcome to this explainer, where we're going to map out humanity's bold return to the moon and eventually all the way to Mars. Let's dive right in. Okay, so here is our flight plan for today. First, we'll meet the Artemis program itself, tour the massive new rockets getting us there, walk through the exact mission timeline, explore what life on a lunar base actually looks like, and finally, check out how this is all just a stepping stone to Mars. Section 1. Meet the Artemis program, the new era of lunar exploration. To start, we really need to understand what this program is. Fittingly named after Artemis, the Greek goddess of the moon and the twin sister of Apollo, this is completely different from the 1960s space race. We aren't just going back for some quick footprints and flags in a brief, government-only sprint. No, this time we are going back to stay. And we're doing it with a huge commercial and international coalition. The goal isn't just a quick visit, it's building a permanent foundation. Now, as you can imagine, building a permanent off-world foundation requires an absolutely immense investment. Modern spaceflight procurement is incredibly complex. A 2021 audit estimated the total cost of the Artemis program, and yeah, that includes all the budget overruns and schedule delays, at a staggering $93 billion between 2012 and 2025. This covers the development of entirely new classes of rockets, habitat modules, and landing systems. But here's the cool part. NASA isn't footing the bill or doing this all alone. As of May 2026, 67 different countries have actually signed the Artemis Accords. It's a non-binding set of principles grounded in the 1967 Outer Space Treaty. It just goes to show that this is a truly global effort for peaceful civil exploration. We're making sure that as we expand out into the cosmos, we're doing it cooperatively. Section 2. Hardware getting us there. The vehicles of Artemis. All right, let's talk about the hardware that's actually physically getting us off the Earth. The aerospace industry absolutely loves its acronyms, and a really crucial one for you to know here is the HLS, or Human Landing System. This handles the final leg of the journey right down to the lunar dust. Because the main launch rockets stay in orbit, we need these specialized ferries, which are built by private commercial partners like SpaceX and Blue Origin, to actually touch down on the surface. It's honestly wild when you look at the sheer contrast in our launch vehicles. On one hand, you have the immense power of NASA's Space Launch System, or SLS. That rocket will carry the crew, taking 95 metric tons to low Earth orbit for roughly $2 billion a launch. Compare that to the commercial rockets. SpaceX's Starship is aiming to lift 200 metric tons for a goal of just $2 million per launch. And Blue Origin's New Glenn handles 45 metric tons for about $68 million. These companies are aiming to drastically bring costs down through reusability for the landers and cargo. So, where are the astronauts during all of this? Well, they'll be riding out to lunar orbit inside the Orion spacecraft. It's a state-of-the-art, partially reusable capsule featuring a sleek glass cockpit actually modeled after the Boeing 787. Plus, it's supported by a European service module built by Airbus, which provides all the vital life support and propulsion to keep a crew of 4 alive out there in deep space. Now, when you're dealing with architecture this complex, you have to be agile. It is definitely worth noting that NASA originally planned to build a whole space station in lunar orbit called the Gateway, but they actually canceled it in March 2026. Why? To shift their focus entirely to developing the lunar surface base. It was a strategic move to streamline the mission and get boots on the ground faster. Section 3. The mission timeline, mapping the flights. Okay, with our vehicles assembled, let's map out exactly how this flight plan works. The timeline really shows the escalating complexity here. We started with the Artemis 1 uncrewed test flight back in November 2022. Then came the Artemis 2 crewed lunar flyby in April 2026. Next up is Artemis 3 in late 2027, where we test the landers and suits in low Earth orbit. And all of that culminates in early 2028 with Artemis 4, the first actual lunar landing, followed quickly by Artemis 5 in late 2028 to start building the base. Just to give you a sense of scale for these test flights, during that Artemis 2 flyby mission in 2026, the crew traveled 252,756 miles away from Earth. That officially broke the distance record set by Apollo 13 over 50 years ago. They literally pushed the Orion capsule to its absolute limits.
So the real pivotal moment happens in early 2028 with Artemis 4. That's when astronauts will finally transfer to a commercial Starship or Blue Moon lander in orbit and descend to the lunar surface for the very first time since 1972. Two crew members will step out to conduct extravehicular activities. And then right on its heels, Artemis 5 arrives to begin the real construction of our permanent off-world home.
Section 4. Life on the lunar surface. The Artemis Base Camp. Think about this for a second. How do astronauts actually survive and operate for up to 2 months in the extreme environment of the lunar South Pole? I mean, it is the ultimate survival challenge. The base camp is going to be located near deep craters, specifically Shackleton and Dejarloc, so they can harvest water ice. But just operating there requires unbelievable technology to withstand the brutal temperature swings, cosmic radiation, and that razor-sharp lunar dust. So, the base camp essentially relies on 3 core modules. First, you have the surface habitat, which is the foundational dwelling structure. Second is the lunar terrain vehicle, basically an unpressurized cart for local trips up to 20 kilometers. And finally, the crown jewel, a massive pressurized rover built in partnership with JAXA. This Japanese-built rover acts like a deep space RV, meaning astronauts can explore for up to 30 days without even wearing spacesuits inside. How cool is that?
But of course, when they do step outside those habitats, they're going to need some serious gear. They'll be wearing the next-generation AXM-U spacesuits developed by Axiom Space. Remember those stiff, pressurized balloons from the Apollo days that forced astronauts to do that awkward bunny hop across the moon? Yeah, these are nothing like that. These commercial suits provide critical joint mobility. Astronauts will actually be able to bend over, walk normally, and do heavy construction right in the lunar dust.
Section 5. Stepping Stone to Mars, the Horizon Goal. Let's zoom out to the ultimate horizon here and understand why this massive lunar effort really matters. The foundational 2017 Space Policy Directive that originally launched Artemis makes it perfectly clear. The goal is, and I quote, to lead an innovative and sustainable program of exploration to enable human expansion across the solar system. The moon is not the final destination, folks. It is a proving ground. By establishing this base camp and staying for up to 2 months at a time, astronauts are testing the exact survival technologies that are absolutely mandatory for surviving on Mars. We're talking long-term habitat sustainability, extended surface mobility, advanced life support, and in-situ resource utilization. You just can't learn how to extract water ice from alien soil or run a closed-loop life support system by staying close to home in low Earth orbit. You literally have to get out there and do it in the dirt. It leaves us with a really fascinating thought about our interplanetary future, and honestly, a fantastic reason to keep your eyes glued to the night sky in 2028. The engineering, the rigorous trials, and the triumphs taking place on the moon right now are paving the way. So, when the first humans finally step onto the red dust of Mars, how much of their success will be owed to those ice-filled craters of the moon?